All right, let's just jump right in. There's some big news making waves. The AI lab, DeepSeek, is going to be training some of its models using Huawei's Ascent chips. Now, this is a much bigger deal than just swapping out some hardware. It's a really smart strategic move that could seriously shake up timelines, pricing, and who actually gets to ship the next big AI model first?
And of course, this brings up the billion-dollar question, right? Is Nvidia's total dominance actually at risk here? We're going to break down what this really means, not just for the chip wars, but for literally anyone who's building, investing in, or just creating with AI today.
So, to really get why a top-tier lab like DeepSeek would even consider this, you first have to understand the massive problem that pretty much everyone in AI is facing. And that's the bottleneck. It's this sort of hidden pressure that's been quietly derailing AI roadmaps for months now.
I mean, for well over a year, the demand for these high-end training-grade chips has been absolutely off the charts. You've got all these brilliant, ambitious projects, the kind that are supposed to push the whole field forward, and they're just slamming into this huge wall of limited supply. And the real-world consequences of that, they're brutal. We're talking about teams facing these crazy long waiting lists for compute time, and even then, their spot can get snatched away at the last minute. You miss one of those slots, and boom, your whole project gets kicked to the next quarter. This isn't just some small inconvenience. It completely crushes your team's momentum and can even damage your credibility. It's that kind of pressure cooker environment that's forcing people to look for another way.
And that other way is this idea of opening up a second lane. Now, this is not about abandoning the fastest lane on the highway. It's a much smarter strategy, really. It's about targeted diversification, all designed to get work started and to keep it moving.
So let's be super clear about what this second lane strategy really is. It is not about a massive exodus away from the best-in-class hardware. No way. It's about adding a workable, a good enough alternative into your toolkit for one incredibly important reason: to make sure that your work can start the moment your team is ready, not when a slot on a calendar finally, hopefully, opens up.
And this gets to the very heart of the strategic trade-off. For so long, the entire industry has been obsessed with theoretical peak performance, the biggest numbers on the spec sheet. But what actually delivers value? It's not always the absolute fastest chip. It's the ability to ship your product on time. Having a dependable rhythm is so much more valuable than waiting around for the absolute best. And starting now is almost always going to be waiting for a slightly faster option down the road.
I heard a quote that just nails this idea perfectly. A second lane turns blocked weeks into learning weeks, and learning weeks into shipping weeks. Just let that sink in. Every single week your team is blocked just waiting around for compute time is a week you're not learning, not iterating, not getting closer to shipping. In a market moving this fast, that's an incredible advantage.
Okay, so that's the theory. Let's make this concrete. Let's look at how this actually plays out in the real world, with 4 scenarios where having that good enough second option is actually the winning strategy.
Just think about it. Maybe you have a support bot with a launch date that is absolutely set in stone, but the main cluster is booked solid. A second lane totally saves the day. Or what about a weekly model refresh where that predictable rhythm is everything? Or maybe you're building an enterprise model that has to meet some specific regional compliance rules. Even in research, you can run all your earlier, cheaper experiments on the second lane before you move to the more expensive hardware for the final push. In every single one of these cases, the good enough option gets you the win.
So, this naturally brings up a really critical question. Just how much of a performance hit can you actually take for this second lane to still make sense? Let's just throw a number out there. Say it's 10% slower.
And here's the key insight, the part that can change your whole perspective. A lane that's 10% slower but is available right now, today, will almost always beat a faster lane that you can't get for another 6 weeks. And why is that? It's because the calendar, not the clock speed, is what ultimately decides who wins the market.
Now, of course, none of this matters one bit if the alternative technology just isn't ready for prime time. So let's get into the weeds a little bit and look at the tech stack. What has to be true for a second lane to be a genuinely viable option for a serious engineering team?
This is basically the checklist that engineers live and die by. Is the software mature enough that you can run your PyTorch code without a ton of edits? Does the whole system scale nicely when you add more nodes? Is the numeric precision stable, especially with new formats like FP8? Are you getting weird random errors, what engineers call nans or not a number? Critically, can you recover from a glitch in minutes instead of losing a whole day? And finally, is the developer experience any good? I mean, if the tools are a nightmare to use, nobody's going to adopt it. An alternative has to clear every single one of these hurdles.
Okay,
So let's zoom out again, because the emergence of credible second lanes is going to completely redraw the entire AI map. The ripple effects from this go way, way beyond just one company or one product.
And what's really interesting is that everyone is looking at this shift through a totally different lens. Hardware analysts, they see it as smart risk management. Policy watchers see it as regional strategies finally starting to mature. The practitioners, the engineers on the ground, they're laser-focused on the developer experience. And the investors? Well, for them, it's about resilience. It's like an insurance policy against supply shocks and sudden price hikes.
So if you're a builder out there, what can you actually do today? Here are 4 quick, practical steps you can take. First, start a small pilot project. Second, map out all the specific operations your models rely on and check their compatibility. Third, and this is a big one, test the numeric stability with your actual data, not just some generic benchmark. And fourth, track your recovery times like a hawk. That's a massive indicator of whether something is ready for production.
And as you look toward the future, here are the signals to watch for that'll tell you this trend is really picking up steam. You'll see more independent teams sharing credible results from their runs on this alternative hardware. You'll see software updates coming out fast, targeting real-world problems. The idea of two-phase training, doing the bulk of the work on a second lane and the final polish on the fastest, that will become normal. And finally, you'll see a whole ecosystem of cloud providers and MLOps companies spring up to support it. That's when you know the shift is for real.
But really, when you boil it all down, it comes back to this one powerful idea. 2 engines beat 1. Having a portfolio of compute options instead of just waiting in a single line gives you a massive strategic advantage. Because, as we've seen, it's the calendar that ultimately decides the winner.
So I'll just leave you with this final question to think about for your own work. Take a look at your own projects, your own timelines. How would your roadmap change if you stopped just waiting in line and instead started actively managing a whole portfolio of compute options? That shift in thinking, that right there might be the biggest takeaway of all.